Hello, I'm Eric Snodgrass, Principal Atmospheric Scientist at Nutrien Ag Solutions, and I want to thank you for giving me some time here at the very end of the year to talk to you about the weather. We're going to talk about the long-range outlook for winter and early spring. We're going to talk about what's going on in South America, but I'm going to ask you for just a little bit of extra time today because I'd like to tell you a Christmas story. But it's a meteorology Christmas story, and it starts in India. That's a topographical map of India showing you in relief here the elevation changes across the subcontinent. Now, one of the most abused terms in atmospheric sciences is the word monsoon. A lot of us just think that a monsoon is just when it rains really, really heavily, but it turns out the monsoon is actually a term we use to describe these large-scale circulations. Now, we have one in India, we have one in Southeast Asia, there's one in Brazil, and I'm going to tell you about that one in a few moments. And there's also one in the southwestern part of the United States. And these large thermally direct circulations work something like this. In summer, we draw in across the subcontinent a lot of very moist air off of the Indian Ocean. And as you look here long ways on India, that flow comes in and eventually hits the Himalayan mountains where it rises. As it rises there, we get clouds of precipitation, and I do mean a lot of it. Some places along the kind of front range of the Himalayas here get anywhere between 150 and upwards of 500 inches of rain in the summer. In fact, there's a place right about here called Cherrapunji that holds the world record at over 1,000 inches of rain. Now, the monsoon is critical to India. Take a look at this map which shows Earth at night. You can kind of see all the lights in all of our cities. There is 1.35 billion people right in through there. And therefore, the monsoon is critical for their health and well-being. If the monsoon is late or if it underperforms, we have problems with drought. We have problems with famine. If it's early and if it's aggressive and if it brings in a lot of precipitation, tens of millions of people are subjected to floods. And this has a major impact on agriculture. So because of that, in the late 1800s, and this is where our Christmas story starts, in the late 1800s, under British rule, India formed something called the Indian Meteorological Department. And their entire goal was initially just to forecast the monsoon. Now, they had some pretty crazy ideas about it, if you ask me. And first thing that they thought was the monsoon was controlled by what happened over Australia. Well, those meteorologists that made those kind of correlations didn't do a very good job, and it was a pretty poor predictor. They then looked a little closer to home, said, well, maybe it has something to do with the snowpack in the Himalayan mountains. Maybe if there's more snowpack or less snowpack, it affected the monsoon. But turns out that was only one very small part of the whole monsoonal circulation. They then said, well, maybe it has something to do with the flooding of the Nile River. Now, this one had me scratching my head a bit, but flooding of the Nile River being correlated with the monsoon just didn't seem to make a lot of sense, and it turned out they did a horrible job predicting the monsoon. So the Indian Meteorological Department did what I thought they should have done, and that was to fire their meteorologists. They weren't doing a very good job. And instead, they hired this guy, a mathematician named Sir Gilbert Walker. Now, he was pioneering some pretty cool mathematical techniques at the time, primarily around the idea of regression analysis, linear regression, autoregression, multivariate regression, basically where you take two sets of observations and you compare them to look at how closely correlated they are. In fact, that was a new term at the time. And he came in and said, you know what, we got to start measuring a whole lot of different things to see which variables are most strongly correlated. Now, I bet he would have loved to have seen this map. This was back in January of 2010. It's a global ocean temperature map where the colors tell you the differences from normal. And what he discovered while studying in India was that right in here, inside of this box, the fluctuations in the ocean temperatures were most critical to how the monsoon was going to perform. He would have loved to have seen this. You see, this is an animation from satellite and buoys showing us how the ocean temperatures fluctuate between warm phases and cold phases. All he had to go on were ship reports, yet he was able to start to recognize this oscillation in ocean temperatures that happen across the Pacific, which is the widest west-to-east expanse of ocean we have on the planet. Now, as he was studying this, he called it the Southern Oscillation, this change in the temperature, precipitation, and ocean temperature patterns, which also included a change in pressure, and that ultimately determined really how strong the monsoon was going to be. We thought he was the first one to find this out, and this is where the Christmas story part comes in this, because after he was publishing his results and we were starting to get better at predicting the Indian monsoon, it turned out we learned that there were some folks right over here that had been observing this much, much longer, much earlier than Sir Gilbert Walker. Peruvian fishermen. And they used to fish the very nutrient-rich waters just off the west coast of South America. They fished for anchovies. What they noted for centuries before this was that those waters would periodically warm up. And what they found was that the peak in the warming of the waters tended to coincide with the Christian holiday of Christmas. So do you know what they called it? They called it El Nino. Now, from now on, every time you hear the word El Nino, which when translated from Spanish means the little boy, remember that we capitalize El Nino because El Nino refers to baby Jesus. Now, why? The peak in the heating of the water tended to coincide with the very end of the year when we celebrate Christmas. And after that, it tended to cool back off again. And on the flip side, whenever it would cool off throughout the year, it tended to reach a peak in cooling right around Christmas. Now, we call the cool phase La Nina. And the reason why we talk about El Nino and La Nina is because it redistributes clouds and precipitation across the widest west-east expanse of ocean in the world. And that affects weather in North America, South America, India, Australia, Indonesia, in fact, the whole planet. Now, what has ended up happening since then is we've combined the terms. And what we now call this is El Nino and the Southern Oscillation. I just thought you might like to know a little bit of that history. So here you go. Since 1950, and I'm sure Sir Gilbert Walker would have loved to have seen this, but since 1950, we've been monitoring these ocean temperature patterns. Big El Nino episodes like 97-98 and 2015-2016, and big La Nina episodes like 2010 to 2011 happen quite often. Right now, we're sitting right here, nearly at the peak of our current moderate strength La Nina. And there it is. Now, we talked about this in our last video, but in this video, I want to discuss with you why it's important to be monitoring the strength of this La Nina, as it will be one of the more dominant factors controlling the background state of the atmosphere. Here's all I want you to remember. La Ninas tend to make the jet stream slower and tend to make it more loopy, big ridges going north and big troughs going south, whereas El Ninos tend to race across the country from west to east, more zonal. That's what we call that. Also, El Ninos tend to develop a much stronger subtropical jet stream component to the flow. Now, thinking about that, California would love nothing more than to have an El Nino this winter. But instead, we have a La Nina, and that means our jet stream is a little bit on the wacky side of things. Now, that's not a meteorological term, but what I mean is it tends to be just bending quite a bit. Look at what it did all year long. This map shows you from January 1st to December the 16th, so mid-December here, precipitation ranks by climate district. We've been keeping observations since Sir Gilbert Walker got us started here, 128 years worth of data. Record dryness, massive drought in the west. You saw all the videos of the fires. 30 named tropical systems causing flooding in the southeast. And when you look right in the heart of the country, we were trapped in between all of it. Now, thinking about that, let's talk about what's happened since we last talked. October, major cold air coming out of the Canadian prairie, then gave way in November to almost record heat coming out of the southwest. You see, this is what you get when you keep the jet stream really loopy during a La Nina. So let's get into a forecast now. Over the last 30 days, this map shows you precipitation expresses a percent of normal. We've been very dry in parts of Texas, in the southwest, and in the northern plains. We've had some very active weather running through the midsection of the country. In fact, while I'm recording this, a huge nor'easter is building here in the northeastern part of the United States, putting down upwards of 25 inches of snow, possibly riding through this area. So the pattern has been active, but it's been practicing avoidance, almost as though it knows we've got COVID, right? It's just staying away from certain regions. I think that's a very interesting thing to see here. So the winter outlook, as forecast by the Farmer's Almanac, why don't we just use this as a backdrop and see if maybe this year the Farmer's Almanac has got this right? Because historically, I'll be honest with you, it's not been that great. But you know what? Long-range weather forecasting is speculative by nature anyway. It's one of the more challenging things that we do. So how about a little bit of near-term stuff? This takes us all the way out to 2 days before Christmas, and you can see the effect of that nor'easter. Look at all the snow here. But through the midsection of the country, not too much coming down here. It's all in the northwest. When we look at total precipitation, there's kind of a big donut hole here from the 16th through the 23rd. We're not seeing a whole lot of activity in that area. Do we have a chance for a white Christmas? Well, here's the nor'easter. Let me show it to you. Stop. Whoops. We'll go back and watch it again and just stop it right there. You see it's racing up to the northeast. There it is. Big, powerful system right through here. But after that, there's not a whole lot coming through the state of Missouri. Maybe a chance of rain over the weekend. I'm talking about Saturday the 19th. The cold, cool rain here. But high pressure tends to dominate. The systems stay north. And all that I have to tell you is that when we get out here to the 23rd, watch for this low pressure system. Might go across parts of the Great Lakes states. It could be bringing a pretty powerful cold front to us right before Christmas. We'll have to see if we get any precipitation out of that. But overall, it doesn't look like our chances of having a white Christmas are very good right now across the state of Missouri. Here's the problem. The jet stream is still quite loopy. See that? And where we are, I'll put a C over it. Now that C doesn't stand for Christmas, it stands for convergence. Convergence in the jet stream. That tends to produce drier conditions. It's also going to be relatively mild. Take a look at this. I was just curious where, see this warm air right in through here is coming from? It's a little bit to our north, but where in the world is that coming from? So I made a map over here on the right that shows the trajectory of it. And you just see that the air, I'll draw it in red here, coming into the midsection of the country is largely mild Pacific air. It's not tapping into the very cold air that we have here over this part of Canada toward Alaska. In other words, go back over to the map on the right. We're not getting, I'll draw it in blue, air that's coming from here. And that's a critical piece to how the temperatures are going to fluctuate as we work our way toward the end of 2020. Notice we tend to favor very brief shots at colder air. You'll get some cold air in place, but they're relatively brief. And we tend to favor just a bit of a warmer bias overall. Now remember, it's December, so to be a little bit warmer than normal still means that it's cold. But as I said, nothing in the way of major winter storms coming as we work our way possibly toward the end of the year. Now, of course, this is a bit of a longer range stretch, and so we might see some stuff come through, but the models at this point, mid-December, aren't favoring it. You ask about the polar vortex. Well, right now it's sitting up here and spinning, and it's pretty strong. It's located right here. There's Greenland. Here's Scandinavia. Here's Russia. It's up there. It's not displaced. It's not disrupted. And just remember, when it becomes really strong like this, it just keeps all the really cold air in place. It's when it's weakened and it splits into multiple pieces and slows down that you get these big cold air outbreaks. Now, for example here, this was back in 2019. This young lady up here in Minnesota took her favorite pair of pants, soaked them in water, tossed them up into minus 30-degree weather. They froze mid-flight and perfectly stuck the landing. One of my favorite videos I've been showing. Well, that polar vortex right now is strong. And I'm just going to let you know, these are all the things I watch all the time. So what I'm going to finish with is I'm going to talk about La Nina. Not only here in North America, but South America and how it affects, look here down here, the Brazilian monsoon. So here we go. Our La Nina is fading. It's reaching a peak. It'll still be around December, January, and February, but look up here in the top left. You see the La Nina was getting cold until December, and it's going to start to warm through January, February, March, April, and May. And more than likely next spring we'll be sitting in ENSO neutral conditions, which means neither La Nina or El Nino. Now at this point, I can't make an accurate projection for spring just yet based upon that. But it'll boil down to a discussion about drought over the Southwest. And this is the reason why. During winter, I expect high pressure to sit off the West Coast, especially through the front half of winter, keeping the jet stream on a path just like that. That's what it typically does when there's a La Nina. And we have a problem with that flow coming through just like this. You see, it's avoiding the Southwest where there's drought. Here's what I want you to know. If by next spring we see this drought expanding farther into the plains over toward Missouri, such that it extends out to here by the time we get into April, then I will be very concerned about our situation moving forward. But if winter tends to bring in a more active pattern, maybe late in January, February, March, that could help erase this. I also have a saying. That saying is, spring rains can undo all of winter's sins. But this drought monitor map is going to be something we're going to have to watch very carefully moving forward. So if we have a La Nina in the background, what would NOAA say would happen? Well, they made a big, massive array of maps. I'm going to distill it down for you. When we have cold air, it will be coming out of the northwest, not out of the north directly, or not out of the Hudson Bay. It's going to slide into the United States like this. And it tends to be drier in the southeast and drier in the southwest. And the active pattern tends to run right in through here, okay? So for the state of Missouri, it looks as though as the farther south you go, we could see some drier conditions down in the southeast. But we're going to probably see a more normal winter in terms of our precipitation. Here's another way of forecasting it. Analogs. I found a grouping of years, they're all right in through here, that behaved very similar to 2020. And 2020 is that thick line you see running through here. What are we looking at? Ocean temperatures. And what we got is a max being reached right here at the number 52. That would be the last week of the year. And it starts to warm back up, this La Nina does. Well, using these years, which look very similar to 2020, I got this. You see, the temperature patterns during those years, look at the map on the left, tended to come out like that. And it was warm to our south. The jet stream pattern liked this. A lot of clipper systems running across the U.S. When we look at those analogs, we see it's quite wet here and quite wet in the Ohio River Valley. We tended to be dry in the Central Plains, and in some of those years, we ended up having a dry January, February, March cutting across the southern part of Missouri. But overall, these are not major precipitation anomalies in this section of the United States, something I want to watch very carefully. Here's another way of looking at it. Over here on the right, I have the temperature anomalies for those analog years, and on the left, I have the precipitation. Now, this is maybe a little bit clearer. Can you see how through Missouri, getting into the Ohio River Valley, we tended to favor wetter conditions? That's on the left. And it also tended to be wet here, with drier down in Texas, right up into the Central Plains. See that? And the temperature pattern, when the cold air came out, you can see where it came from, while we stayed warmer to the south. Let's keep going. This is NOAA's outlook. You can take a look, pause the video, look at it on the left, that's the temperature outlook, and on the right, that's the precipitation. They've got us closer to the more active pattern here. What about the European model? January, February, and March. You see it too. That active Ohio River Valley storm track giving us a lot of storm systems that probably start here in the panhandles and hook through the state of Missouri. We may carry a slight warm bias according to the European model, but it's a degree or two. It's not hot. And then we also run some models in the United States. Take a look. Same active storm track in through here, with the warmest conditions farther to our south. One more look at this. This is from the IRI multi-model group. They got it too. See that active storm track in through there? And when the cold air comes out, it's coming from this direction. You see, with La Nina dominating the background state of the atmosphere, this is what you get. Now, I told you at the beginning I was going to talk about South America too. Give me another couple minutes and I'll show you some important stuff going on there. First of all, South America's production curve, as I'm drawing over here on the right, is exponential. Some numbers tossed around this year is up to 132 million metric ton crop, could be even higher than that. It all depends on how much new acreage came in. Normally, they add about 1.5 million acres every year. That's about 20% of an Illinois soybean crop. And remember, Illinois is the biggest producer of soybeans in the country. They currently only farm 8% of their arable land, and I put Texas, by the way, inside of the state of Mato Grosso. Now, speaking of Mato Grosso, that's an area, listen to this research, okay? That's an area that is seeing, during the end of its dry season, which goes from August to September and October, they're seeing an increase in their vapor pressure deficit. That means October, when they want to be planting a crop, is getting drier. And that happened this year. You see, inside the state of Mato Grosso, look, I'm coloring in it over here on the right. That area, which, by the way, produces the equivalent of an Illinois plus an Iowa soybean crop. Their monsoon was late. Look down here. All of this was where they missed out on some early rains. Then they came on in October and they tried to plant quickly, but then they got dry at the beginning of November and the end of November, 2 dry periods here. Tried to rain to start December, but they went back over dry here mid-December. That's 3 extended dry time periods. Now, very quickly to the south of there, they've recently got better precipitation, bringing up the soil moisture here, but it stays dry in Brazil's central and northern growing areas where I just put that line. That was the beginning of December, looking at soil moisture anomalies. Like I said, to the south, some recent rains help things out. And you're going to see in the forecast it's going to be nice and wet there moving forward. Down into Argentina, same scenario here. Some recent rains have helped things out, but I'm worried about Argentina moving forward. And this is why. You ready? Now, to finish out 2020, this region in through here is going to be much drier than normal, and it's hotter than normal. This is the 3rd extended dry time period right here in Mato Grosso. But then notice, as we then get into the end of the month, adequate rainfall starts to come back in. And the long-range outlook for January keeps this corridor wet, and we start to get drier down here in Argentina. Now, some big questions loom about getting really wet in this area because they start to harvest this soybean crop in January. And if it's too wet, well, if it was delayed going in and wet coming out, the problem might be that the harvest is going to take a little bit extra time, extending the problems here that they could have, that they started having at the beginning of the season. And remember what I told you about that La Nina, right? It's fading. That's all that these graphs say. It's fading. It's starting to fade. So what does that tell us? Well, just like we did earlier, the La Nina, looking at the years that look very similar to it, what did we get? Well, it tended to be wet January, February, and March in this area, just where the models said it would. And it was drier to the south and drier to the north. At this point moving forward, my concern, and that's what the map on the right over there suggests, it could be very wet in this area and impact harvest. But that's pretty far out in this forecast. We're going to have to watch to see that, but I want you to be keeping an eye on it. And then watch for drought development in Argentina. That'd be very typical of a fading La Nina. Okay, I told you I had a lot to cover. I hope you enjoyed my Christmas story. Hope you now get a better perspective of what's happening around the world, not only for our winter, but for what's going on in the growing season in South America. Hope you all have a safe and happy Christmas and New Year, and we'll hopefully talk to you again very soon. Thanks.